All right. So we will now transition from, I think, the hardest thing we do all semester to the easiest thing we do all semester. So we're like, we're legit doing like Algebra 1 topics.
This is something I'm gonna pay attention. I'm gonna get a 50%.
Don't do that. Don't do that.
Just don't get a 2%.
Don't do that either.
How is that humanly possible?
All right. So starting off, we're going to talk about, like equations and formulas. So when we say something is a solution, what is that?
It's an answer.
It's like a value that satisfies an equation.
Yep.
Okay, so Sam.
What's a solution set then?
Oh, a solution set?
What?
Set of values. All the values inside?
Yeah, it's a set of all values.
That's all equations.
Yep.
Oh, just give me the underline.
I'm so proud. Can I have a piece of that too? Sir?
What's an identity then?
It's like what you choose to be.
In mathematics though.
Oh,
It's like in trig.
Yeah, so it's like an equation that's true for all values. So for example, since trig was mentioned, like cosine squared plus sine squared equals 1 is considered an identity, because regardless of what value you pick for theta, that is always true for all values of theta, right? So let's say we have the equation 2x minus 4 is equal to 6. What's the solution for that? So we say x equals 5 is the solution, and then the solution set would be the set of one number, just 5. Everybody's cool with that? What's an example of an equation that might have more than one thing in its solution set? Quadratic. How many would you expect to see? Possibly 2, right? Could just have 1, right? Like if it was, like x squared plus 4x plus 4 has just one solution, -2. But typically you get, at least, 1, 2, or 0. Real solutions anyways. Anyways, what's a formula then? Well, it's an equation, usually with more than one variable. And often has parameters or constants in it. So for example, the area of a circle is pi r squared, right? So a and r are variables, but pi is a parameter, it's a constant, right? Or if you guys are in chemistry mode, PV equals nRT. PV, N, and T are all variables, but R is a constant. That's a gas law formula. Yeah, that's okay. That's all. It's not important. I don't think you probably do it in honors chem. It's probably you do an IB. Yeah. Gas laws.
Oh, yeah.
Yeah, that's super. I don't know anything.
So let's do a little practice on solving to rearrange equations. So let's say we have the equation a squared plus b squared equals c squared, and we want to solve that for b. What should I do first? Subtract a squared from both sides. Great. Then what? Okay, do the square root of both sides. That's great. Oops. Okay, anything else? Well, radicals do not distribute across addition and subtraction, so this is not equal to b or c minus a. So don't say that. But there is something that's missing.
Plus and minus.
Yeah, way to go, Nora. Party time.
I know. Did you just say about time?
No, I said party time.
No, it's so true though.
Okay. What if we have this equation? We want to solve it for L. What should I do first?
Is that J? What is that?
Divide both sides by 2 pi. And then what?
Square both sides.
Okay.
Wait, look for L?
Yes, we're solving for L. Mhm.
Okay.
And we could continue going on simplifying this, right? How do you square a fraction? You square the top and the bottom. So that would be like gt squared over 4 pi squared. This is bad.
Oh, so like the top one's an answer and the bottom one is like reduced?
They're both equivalent answers. Just one's a little bit more simplified than the other. But depending on, the directions, they're both correct in that L is by itself. The last example we have, I equals NR over R plus little r. I think this is for like electrical impedance or something. We want to solve this for capital R. What's different about this equation than the previous ones?
That's the thing.
Yeah, the variable's in more than one location, right? Right, we're solving for capital R, but that capital R is in more than one place.
So we just divide.
Nope.
Divide by.
Yeah, you'd want to multiply by R plus R or cross multiply. That's either way of thinking about it sounds good to me. Okay. Now what should we do? Nope, don't want to divide by n. Yeah, let's distribute the I because we want to get those capital R's on the same side, right? Nope. We want to subtract by, we're going to subtract by IR. So that the capital R's are on the same side. But they're still in two locations. I need to get it into one location. How do I do that? What? Capital R. Somebody whispered it. What was it? Yeah, we can factor that capital R. And then if we divide by n minus I, we're there, right? Hi, Alana. How are you?
Good.
Maria, for you, the University of Spring Arbor. I think they want you.
I'm gonna have to decline.
You have to go there. You have to go there.
Where are you going? Where are you going?
2 hours. It's gonna sell.
Yeah, it's kind of by Jackson. in between Jackson and Ann Arbor. All right. Next thing we're going to talk about are linear equations. The hallmark of any linear equation is slope. We represent slope with the letter m, and we find it by looking at the vertical change divided by the horizontal change. So if you have 2 points, x1, y1, and x2, y2, slope is y2 minus y1 over x2 minus x1. Who still has that memorized? I hope everybody. It is slope. All right. So the IB has 5 different ways to write equations for line. And their vocab and symbols sometimes look a little bit different than some of the things that you would have called and used in your American math classroom. So instead of saying standard form, they say general form. So it'd either be like ax plus by equals c or ax plus by equals c. But the catch here is that almost always they're going to say that those a, b, and c have to be integers. This is usually the hardest one to write because you end up having to clear a fraction at the end, and almost always you forget to do that. The second type is called this gradient intercept form. In IB speak, gradient is slope. So their gradient intercept form is y equals mx plus c. It's the same thing as b, it's just they're using a different letter, like who cares? M is the slope, 0 comma c is the y-intercept. Same as before, just a different symbol. Like, okay, whatever. That seems annoying, but fine. There's the point gradient form. We call that point slope form. So if you have some point on the line, x1 comma y1, then the equation for a line is y minus y1 equals m times x minus x1. Same as the point slope formula that you probably remember from, pre-algebra, algebra, and geometry. Probably did it all 3 times. And maybe again in algebra 2. And then we have 2 special cases. So if you have a horizontal line, the equation is just y equals c, where, c is a y coordinate for every point on your horizontal line. This is technically both slope-intercept form and standard form, or I should say general form. See, look, I can't even do it. I'm stuck on my vocabulary. And then the other one is the vertical line form. This is usually the one that confuses students. This is just x equals c, so that every x coordinate, or every point on this line has x coordinate c. Remind me again, what's the slope of a horizontal line? 0. What's the slope of a vertical line? Undefined. What kind of fraction is undefined? 0 on the bottom. What kind of fraction is 0? 0 on the top and non-zero on the bottom. Right? 0 over 0 is still undefined. In fact, that's worse than undefined. That's indeterminate. But until you take a calculus class, that's not worth going into. Everybody feel okay? Again, hopefully that all looks familiar. All right, let's say, without using our calculator, let's say we want to sketch an equation or sketch a graph for each of the following equations for lines. So the first one, 5x plus 3y is equal to negative 6. What do we want to do here?
y2 minus y1.
I want points, right? How many points do I need? 2 at minimum. Which 2 points are going to be the easiest to get from general form typically? The x and y intercepts. Great. So if x equals 0, what does y have to be? We're looking at A, not 1. Yeah. So what does y have to be then? 2, right? Because 3 times 2 minus 6 equals 0, right? 2 satisfies the equation. That's right. What do we get? Now let's let y be 0. What does x have to be? Give you a hint, it's a fraction. 6 over 5, or 1.2, that would be fine also. No, regular 6 over 5. How about for the next one? What do you notice here that's different about part A? There's no x. What is that telling us? X can be anything, right? It's like a free variable. We have a horizontal line. That's absolutely right. So I can pick x to be anything I want. Maybe I'll do 0 and then I'll do 1. What does y have to be? 4. Oh. Maybe try to make it more to scale. It'll be up there. Okay, if I look at the third one, what do I notice here? There's no y. So again, y can be whatever we want it to be. I'll just pick it to be 0, then 1. What does x have to be? -3. So there, that's something like that. You guys feel okay? Hopefully that's pretty familiar doing. I didn't go through a lot of depth there because, Lord help me, we're talking about graphing lines here, guys. If you do like to do it some other way, I'm sure that it would have been fine. I trust that you're able to graph lines at this stage of the game with a fair degree of accuracy pretty quickly. All right, next example says, find the equation of a line that passes through the point 3, 31 and has a gradient of 12. Write the equation in gradient intercept form. So to do gradient intercept form, that is y equals mx plus c. So we need to find m and c. Which one of those is going to be easiest to get first? Which one is easiest to get first? M. What's M? It is the slope, so what number goes there? 12. Great. So how am I going to get the C? What haven't we used yet? The point that we're given in the problem.
3.
It's not 3. It is not. Oh, 3 is x, sure. So we're going to plug in for x and y and then solve for c, right? So I do that, I get -5 for c. Okay. Does that all look familiar to you guys? Oh my gosh. Part B says, find the linear equation in C and F, knowing that when C is 10 and F is 50, and that when C is 100, F is 212, then solve for F in terms of C. What type of equation for a line are we asking for if we want F in terms of C? Means it needs to start F equals. It's going to be like a slope-intercept equation, right? It's probably what we want to use. Everybody feel okay there? So we need to find the slope and the y-intercept. How am I going to get the slope? I'm going to think about these as 2 points. Yeah, so I'm going to just use my slope formula. So that gives me 9/5. You guys could all do that quickly in your head, right? There was a clue in the problem how I knew that was going to be what it was, by the way. I already know the answer to this without actually doing the problem, just because of the numbers it gave me. All right. So now what do I do to solve for the slope or the y-intercept? Plug what in? Which numbers?
And then the C, which would be the point. That's Y.
Yeah. Does it matter which one I use?
No.
This is one I'm going to use, though. So that's going to be 18 there. So that's going to be 32 is C. Who recognizes that formula? What is it? It's the conversion from Celsius to Fahrenheit. How did I know that was going to be what I was looking for from the numbers based in the problem?
100 degrees Celsius.
100 degrees Celsius and 200 degrees Fahrenheit are both the boiling point of water. So as soon as I saw that, I knew what I was getting. Like, there's going to just be the conversion between Celsius to Fahrenheit or Fahrenheit to Celsius. And when I read the rest of it, it's like F equals, okay, so it's Celsius to Fahrenheit. All right. So that's that. Whatever. Parallel and perpendicular lines. How do I know if two lines are parallel or perpendicular?
If they're parallel and at the same slope, the perpendicular, they have the opposite slope. It's not like reciprocals.
Negative reciprocals, yeah. Or something else. That doesn't cover all cases. What lines don't have any slope?
Non-linear lines.
Nope.
Wait,
Right. What lines don't have slope?
Non-existent lines.
Not that one. That says slope 0. Vertical. So what can I say about two vertical lines?
I said vertical.
Always going to be parallel.
They're parallel also, right?
Always going to be parallel.
And then what is a vertical line perpendicular to?
Horizontal.
Yep.
Good job.
So again, you can't say undefined equals undefined. Equals doesn't work that way. But two vertical lines are parallel. Like 0 over 1 and 1 over 0 are not negative reciprocals, but they do represent a vertical line and a horizontal line, which we know are perpendicular. So we have to have that extra little caveat there. All right, so let's say we have the equation y equals 3/5 x plus 2. What's the slope or the gradient? And what's the y-intercept? Mm-hmm. What's the y-intercept? Usually we want to write as a point. So like 0, 2, right? Everybody's okay there? Find the equation of a line that passes through the point 1, 5 and is parallel to that given line. What's the slope for my line? 3/5, because it's got to be parallel. So let's say 5 is equal to 3/5 times 1 plus c. So c is 22/5. Find the equation of line that passes through the point 1,5 and is perpendicular. What's the slope going to be for this guy? -5/3. Notice that I'm like making common denominators and doing all that stuff while just whoa. Perpendicular, negative reciprocal. Cool? Parallel, equal. It's all right. Line L is given by the equation 3y plus 2x is equal to 9, and point P has the coordinates 6, -5. Explain why P is not on line L. How do I do that? Great. What's going to happen when I plug P into L? It's not going to equal 9. Let's just check that. There we go. That's my explanation. You guys happy there? Okay. How do I find the slope for L?
Oh, sorry. Solve for x. Or solve for y.
Great. What do I get when I solve for y? -2/3 x plus 3, right? That's also L. So what's that tell me the slope is? -2/3. What will be the gradient of the line perpendicular to L? Good. And then what's the equation of the perpendicular line to L that passes through that point P? Everybody's okay? Same old, same old. Just kind of doing multiple steps at once, right? Everybody's okay? Skipping a little bit of the arithmetic? Of course, I think it's your time. You ask every day. And just thought it was past your time.
Alright, Mr. Fuller.
All right. Next up, we're going to talk about solving systems of linear equations. As you recall from your previous classes, there would be 4 major ways in which we'd solve a system. The first would be graphing. So looking at the graph of the 2 lines. Typically, we would use our calculator to do that. Then substitution, elimination, the algebraic methods, and then other technology where not including graphing. What are we really meaning here? Matrix. Using a matrix to solve that system. Oh, it's so quick and nice. Okay. When we solve a system of a system of linear equations, we can get exactly 3 types of solutions. The lines can intersect at exactly 1 point. They can intersect at infinitely many points, i.e. every point on the line is an intersection because the 2 lines just overlap and coincide. Or there can be no solution where the 2 lines never intersect, i.e. they're parallel. Everybody's cool? Hopefully usually we remember that pretty good. This example says, use the graphical features of your calculator to solve each linear system. So we're going to graph this on our calculator and find the solution. In order to graph this on our calculator, how do my equations need to be written? They need to be slope-intercept, right? Y equals. So what is that first equation when I write it as y equals? Negative 2/3 x plus 2, right? What's the second one going to be? Yes. Okay. So I go and I type this into my calculator. Negative 2/3 x plus 2. Notice that the y equals part is already in my calculator. You guys know that already. And to graph this, I'm going to pick zoom and standard. That just graphs it on that normal negative 10 to 10 window, which is, for a problem like this, is where I'd expect the solution to lie. Because if I don't see the solution on my screen, my calculator can't find it graphically, right? Oh, there it is right there. How do I get that actual numbers? Second trace. Which command am I looking for? 5. Intersect command. I need to supply the calculator 3 things. To use this, it needs to know which 2 lines are we looking for, and then needs a guess. How many lines have I graphed? Just 2. How many intersections do I have? Just 1. Guess what? None of the inputs matter. All I'm going to do is press enter 3 times, and it's just going to spit it out for me. I get negative 3/4. So as long as you're just graphing 2 things, and there's only 1 intersection, just press enter 3 times. None of the inputs matter. The calculator knows what to do. All right. Problem B. What's my first equation got to be? Good. And the other one? Yeah, that was too much delay on that one. That was the easier of the 2. You did the first one faster. It's okay. I'm just giving you a hard time. There's no reason this can't be fun, right? Oops, forgot my X. Okay. Same idea. My window's already set, so I just press graph. Do. Second trace, intersect command, enter, enter, enter. And I get, yuck, what the heck is that? What should I say here? How many decimal points should I give? 3. Sig. Figs.
2 past the decimal.
Okay. What's that first, what's the X coordinate?
1.36.
The Y coordinate.
Negative 2.09.
Great. If you did this algebraically, you could have found out that that was 15/11 and negative 23/11. But getting that out of your calculator from the graph, not really a way to do that. All right. let's do elimination to solve this system. What do I need to do to do elimination here?
Solve for x or y.
I want to multiply by one or both of the equations by some constant, possibly different, so that when I add them together,
X or y goes by
one of the variables cancels out. Great. Which variable do you want to cancel out first?
x.
Great. What do I need to multiply the first equation by?
2.
Okay, the second equation.
Negative 5.
-5.
Ooh, yeah.
So that's going to give me 10x plus 6y equals 18. And then negative 10x plus 20y equals negative 60. If I add down, I get 26y equals negative 42. So y is equal to what? Oh my gosh, guys. Try again. That's 70. Good. I was like, why isn't that not working out? I knew this answer is supposed to be a whole number answer. Great googly moogly. All right. So that's negative 2. Once I have that, what do I do with that? How do I get x? Great. Where do I plug it in?
Right back into the one of the equations.
Any one you want, right? Which one do I want?
Let's do those second one. We'll explain those.
All right, sure.
Yeah. I see what you did. I did see that you did that.
So there we go. You guys all remember kind of doing this? Pretty easy. Okay. How do I do substitution? Great. Which variable would be the easiest one to isolate?
Y.
Y. Good. What does when I get the y by itself, what do I get? I like that answer better. All right. And then what do I do with that?
Substitution's only good if you don't have something bigger than one.
So now I have x equals negative 4/3. What do I do with that? How do I get y? Where should I plug it in? Yeah, I plug it in here because the y is already by itself. That's the easiest place. But you could plug it into one of the first two equations. You guys feel okay there? Let's real quick remind you guys how to use a matrix to do this. So I'm going to just do this same problem as a matrix problem. In order to do one of these as a matrix problem, they have to be lined up so the x's are on top of each other, the y's are on top of each other, the equals are on top of each other, and the solutions are on the right. Okay, if it's not lined up like that, you have to rearrange it so it is. So I'm going to press second and the matrix button. I'm going to go over to the edit tab. This equation has 2 rows because it has 1 equation, 2 equations. And it's going to have 3 columns, one for the x's, one for the y's, and one for the answers. So I need a 2x3 matrix. And then I'm just going to type in the coefficients from my problem. Everybody's okay there? Make sure you take the negative signs with you. So I just did 3, -1, -9, 6, 2, 2. I'll exit back to the main screen. And this time I'm going to do second matrix. I'll go to the math command. I'll scroll all the way down till I find the RREF command. And I'll do that on that matrix A that I just built. So I press enter. The first row says that 1x plus 0y is equal to -1.33 repeating, or just that x is equal to that. The second row is 0 plus 1y is equal to 5, or just that y is equal to 5. The cool thing about the matrix, though, is if you do the math and then frac command on it, it'll go and convert those decimals into fractions in a way that when you do it graphically, you cannot. It's a pretty good deal. So far, so good. All right, what if we have a story problem? Oh.
Let's do it.
All right, when flying in still air, i.e. no head or tailwind, with its propellers rotating at a particular rate, a small airplane has a speed of s kilometers per hour. With the propellers rotating at that same rate, the airplane flies 473 kilometers in 2 hours as it flies against a headwind, and 887 kilometers in 3 hours with the same wind as a tailwind. Find S and the speed of the wind. Yes, it does. So I'm going to use, my two variables are going to be S and W. S is going to be the speed of the plane in kilometers per hour, and W is going to be the speed of the wind in kilometers per hour. Everybody feel good? Since it asks for speed, and I use W for wind. Okay. So, Sam, as I correctly identified, that this sounds like a system of two equations problem. So I have one system for the first piece of information, or the first situation, and then one equation for the second situation. Everybody feel good there? All right. Since my variable that I'm solving for is in kilometers per hour, what kind of quantity is going to need to be multiplied to that? So my variable is in kilometers per hour. What is the unit of the number that should be multiplying to that? Hours. So when they cancel out, when the units cancel, you're left with only kilometers, because that is also given to me in my question, right? So for the equation 1, I'm going to have 2s. Everybody's good with y2? Because it said 2 hours. Okay. And then I know that this is going to somehow equal 473. But what is the headwind doing? Is that going to be slowing the plane down or speeding it up? Slowing it down. So it's going to be minus. And then what? 2w, right? Because the wind speed is still time, right? Or you could think about it as like 2 times s minus w, right? If you want to think about it that way, you could do it that way also. All right, now that we've done that, who can tell me what equation 2 should be? Yeah, that's what I'm talking about. Who is that masked man? I thought that was a good joke. All right, so I'm going to solve that system via a matrix because, boy, that's quick. And the numbers here are kind of nasty. and it makes life real easy if you're good at it. So there's my answer. Let's round that to 3 sig figs. What's my answer for S and W? So my value for S should be 266, and my value for W should be 29.6. Why am I omitting the negative? Speeds do not have sign. Velocities can be positive or negative. Speeds are only positives. They're absolute values of velocities. Right? Physics people know this. If you're not in physics, I'm telling it to you now. Yeah, he knows. All right. Next section. We're going to start with a relation. We're talking about relations and functions here. A relation is just a pairing between two sets. One way we often do that is with what's called a mapping diagram. Oops. So we call one set the inputs and one set the outputs. You know, and like we draw some arrows to show the pairings, and like that's a mapping diagram. You guys remember those, seeing those in Algebra 2 probably? Okay. Input is really the same as the domain, right? Output the same as the range. What's a function then? It's a relation where every input is paired with exactly one output. Yeah, we'll do that. All right. Let's take a look at some of these functions. We're going to decide whether it's a function or not, and then give its domain and range. Is this mapping diagram represent a function?
No. Yes, it does. Wait, hold on. It does.
Yes, right? Every input has an output, and each one of them only goes one place. Okay, what's the domain? So since there's finitely many things in my domain, it's just going to be like elephant, goat, horse, rabbit, tiger. I can just list them using the set bracket. And the range is just 10, 25, 50. Okay. What about this example? Is this a function?
No.
No, why not? Good, they go to more than one location, right? Okay, what's the domain? 125. What's the range? 0, 1, 2, 3, 4. Everybody feel good? Okay. How about this guy? Does this graph represent a function?
Yes.
Yes, why? Passes the vertical line test. Very good. What's the domain? Excellent. It's all real numbers. Again, you can assume that like the graph is going on forever. What's the range going to be?
1 to infinity.
Great. What are the symbols at the end?
So you can get a closed bracket. Yeah, the square bracket and circle. Yeah.
Perfect. Why is the 1 get a square bracket rather than a parenthesis?
It's actually hits 1.
Because the y coordinate of 1 is actually used. Correct. Very good. What about this guy? Is this a function?
No.
Okay, what's the domain?
1 and 2. Yeah.
Very good. bracket. What's the range?
Negative infinity and positive.
Very good. All real numbers once again. You guys feel good? Usually do a pretty good job on this. Let's write some equations that are functions. So it says express the volume V of a cube as a function of the length of each edge. So we'll say V of E equals, how do I find the volume of a cube? Length times width times height. The length is E, the width is E, and the height is E. So E cubed. It's okay. Part B says express the total surface area of a cube as a function of the edge length.
6e squared.
Excellent. So again, one side or one face is E squared. How many faces are there on a cube? 6, the same number there is on a dice. 6e squared. All right. We're going to do the domain of each function. So what's the domain of this set of ordered pairs here? Excellent. Just the listing the x coordinates. What about for the volume of a sphere? Which variable is representing the x's, r or v? R, very good, because it's the independent variable there. What are acceptable values for a radius of a sphere? Can you have negatives? No. Can you have 0? No. Any positive? Okay, so what do I write here?
So like close bracket 0, or no, open bracket 0. Open bracket 0. And then
Why is it 0?
Right, that's why we use the close or the open bracket on it, so it's not including 0, right?
Could you use close bracket 1?
No, because you can have a half. The radius could be a half or something, right? Okay. What about y equals 5 over 2x minus 6? What values of x make this function undefined?
3 doesn't work, so you have to be like, all this sort of set.
So it's x not equal to 3, but how do I write that with interval notation?
Oh, it'd be like negative infinity to 3. Yup. Then union. Yup. Oh my gosh. Yes.
Everybody's okay there? Remember doing that? Okay. How about the next one? What about D? What values there give us undefined? Negatives underneath the radical, right? What values of x? So x has to be
No, yeah, positive 3. It has to be 3 or
greater than or equal to 3? Less than or equal to 3, right? Well, the square root of, if it's 3, 3 minus 3 is 0. Square root of 0 is fine. We can do that. Square root of 0 is 0. If it's less than 3, like 3 minus 2, no problem. 3 minus negative 5, that's positive 8, no problem. That's what I want. So I'll write that as negative infinity to 3 bracket. Feel okay? Does this all feel like pretty review? This is what most of this semester is going to feel like. Determine the domain and range for this guy. What's the domain going to be? Okay, x has to be greater than or equal to 2. So as an interval, right? You can take the square root of 0. That's fine, right? Okay. Now let's think about the range here. What's the smallest output from square root of x minus 2? It's the smallest value that can take. So 0 then, right? What's the biggest output it can have? Infinity. As x gets bigger, what's going to happen to the output of the square root of x minus 2? It's going to get bigger also, right? So what's the smallest y coordinate that can come out of this? 1. And what's the biggest y coordinate that can come out? Infinity. And since 0 can actually come out of this thing, I know that that 1 should get a bracket as opposed to a parenthesis. Everybody feel okay there? Okay. Find the domain and range of this guy. Let's do the domain first. That should be the easy part. X can't be 2. Good. So how do I write the interval then? It's everything except 2. Right? Everybody's okay there? Sure. All right, let's think about the range here. Nope. If I think about this, this is really just like 1 over some y, right? Because x minus 2 can be any number, can be all real numbers, correct? So just like 1 over y. If I have a fraction where 1 is the numerator, what's the only number I can't write by changing y? 0. Why can't I write 0? Hold on. No. 0 in the denominator, you're right, is undefined. But I can't write the fraction 0. Because what does the fraction 0 have to have? 0 in the numerator. Can I ever make a 0 in the numerator? No. Of course I can't, right? Could I make 10? Sure, I make the denominator 1/10. Could I make negative 14? Sure, I make the denominator negative 1 over 14. Right? I can generate any other y value except for 0. What's the other way to think about this? If you remember from Algebra 2, this looks like a simple rational function. I know that a simple rational function has vertical asymptote at x equals h and horizontal asymptote at y equals k. So the domain and range is going to be everything except for h, and the range will be everything except for k. Yeah, so you could also, that's another notation. So you could say the domain is like the set of all x's such that x is a real number and x does not equal, whatever it was, 2 or something. Yeah, you could write it that way too. I tend to stay away from that because the notation is kind of clunky. And we do intervals. We do the heck out of interval notation usually in Algebra 2 pretty good. So, but that's not wrong. All right. Domain and range of this guy. Great. Or negative 3, right? Okay. And it has to be then also, it also can't be or less than negative 3. Everybody's okay there? So there's my domain, just negative 3 to 3, with opens at the end. What's the range going to be here? So not quite. So if I think about this, between -3 and 3, what's the smallest value this can take down here? I'm sorry, what's the biggest value that the denominator can have? Excuse me. Be 3, right? When x is 0, 9 minus 0 squared is 9, and the square root of 9 is 3. So 1/3 is going to definitely be either the top or bottom of this range. Everybody okay with that? Now, if I say let x be 1, the denominator now, is that going to be bigger than 3 or less than 3? Less than 3, right? It'd be like the square root of 8. Now, 1 over the square root of 8, is that bigger or less than 1/3? It's bigger. If the smaller number's in the denominator, that's a bigger fraction, right? 1/2 is bigger than 1/3. Yep. So is 1/3 the bottom or the top of the range? Bottom. Okay. How high can the range go? Is there a ceiling to it? We've established this much. There is not going to be, right? If I pick x to be like 2.999999999, and I can make that as long as I need to, I can keep getting like 0.00001 in the denominator, which is going to make a massive number, right? Any number you give me, I can make a number bigger than it by picking a number arbitrarily closer to 3 or -3. Does that feel okay? So this is going to kind of look like a parabola, is what this thing will look like. That's kind of hard. But in practice, what would you do to do this problem? What would be the easiest possible way to do this? Graph it on the calculator and look at the picture, right? Super easy to figure it out that way. I like to talk up through it this way so like we understand what we're looking at or how to do it. But like in practice on the IB exam, you will never not have your calculator. That's how I would do this. I just look at the picture, man. Yeah, we can stop here. This is where we stopped first hour. So you guys should do the 2-1 and 2-2 homeworks.